Okay, so we're having a look now back at the unit circle, and what we want to have a look at is which other angles will have the same height, h, as sine 45 degrees. So we're having a bit of an explore to see where there's some other angles that have an equivalent sine value. So to do this, all we're going to do is consider the symmetry of the different shapes. So symmetrically, if I reflect across the y-axis, then there would be another angle over here that would end up with exactly the same height as sine of 45. Now with our angles, this isn't the angle of 45 degrees. We need to also take into consideration that if we start from the positive x-axis and go all the way around, this would be 135 degrees. So we can say that sine of 45 degrees is equal to sine of 135 degrees. And we've created an equivalence statement. But we've left out the whole bottom half of the unit circle. So what about this angle down here? Will it have the same height as sine of 45 degrees? And the answer is yes, h will be exactly the same. All we've created this time is instead of reflecting across the y-axis, we have reflected now across the x-axis. It's still symmetry. So I can look a little bit further and say, well, what is this angle then? This angle goes all the way around to 180 degrees and then 45 more. So that's 225 degrees. So if I come down into this, we call it quadrant. If we come down into this quadrant, we can say, well, sine of 45 is equal to sine of 35, and it's also equal to sine of 225. The only difference is when we go back to our Cartesian plane, we know if this is the y-axis, then this is the positive end, and this is the negative end of the y-axis. So this height won't be positive, it will be negative sine of 225. So we can write this lots of different ways. We can say, well, sine of 45 is equal to negative sine of 225. Or we can say sine of 225 is equal to negative sine of 45. And the purpose of writing this statement is that we can then simplify the equations that we're working with, and we can use exact values.